So now we're going to start what has to be my favorite topic of the whole semester, because I think now you know enough in order to really understand how some of what you've been learning the entire year kind of comes into play in real life and in a very interesting topic. And so we're going to talk about falling bodies. Before we begin, let's kind of see what you already are thinking about falling bodies. So I'd like you to take a few moments, and you're going to read through this sheet and think about what happens when there is air resistance and what's happening without air resistance. Now, don't give this a ton of time. There is no grade. It doesn't really matter if you get them right. The only thing that we've really talked about this year that really emphasizes any of this point is when we watch the video of the bowling ball falling through the air and comparing it to the feathers. And we watched it in that vacuum chamber in the city of Cleveland. And we watched when it was just normal air, how they fell very differently. We watched when they removed the air, and so there was no air resistance, how they fell exactly at the same time. So use that. What you remember from that is kind of a guide to filling this out. And we're going to review this after we cover some topics in here. So pause the video, read through this, kind of give it your first pass, and then we'll go on and talk about some definitions. So we're starting and taking notes. You're going to be adding a few pieces of information to your guided note sheet on page 40. So a few definitions. So in your textbook, it talks about some of this, but if I haven't been having you read your textbook, I'm going to kind of give you the basics. So when free fall, when the force of gravity is the only force acting on an object, we say that the object is in a state of free fall and air resistance is negligible. We call it free fall because there is no air resistance and it's falling free from the absence of any other forces. Since there's always gravity acting on Earth, there will be gravity, but that's it. So we watched the video previously about how this all worked in that large vacuum chamber here in Cleveland, but there's also a video of it on the moon, and this is a hammer and the feather. And so I want to just show this to you so you can see what this looks like.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
All right, so on the moon, he dropped the feather and the hammer and showed that they fell at the same time. And remember, there is gravity acting on the moon, but it's not as not much as there is on Earth. However, there is no atmosphere of air surrounding the moon. So there is no air resistance to be had because there really is no air. Okay, so there is still gravity. It's just not the same as on Earth. So they're actually going to fall at different rates than they would compared to on Earth. But since there is no air, there is not going to be any air resistance. So a question for you. So in a vacuum, both objects fall at the same rate side by side. So is it correct to say that there are equal forces of gravity acting on both objects when in a vacuum? So remember, the force of gravity we determine by the mass times the acceleration due to gravity. So is this true? So no. Okay, the accelerations are going to be equal, but the forces are not equal because what matters is how much mass there is. Okay, so we still have the Earth accelerating with the same amount of acceleration due to gravity. We just do not have the same masses. So for non-free fall, air resistance is going to depend on two things. And we discussed this very briefly earlier on when we were talking about forces. So air resistance depends on the surface area of the object that's in contact with the air. So the bigger the surface area, the more likely you're going to have air resistance impacting it, such as really large jet airplanes. And the second is the speed of the object falling. So at slow speed, you don't see it maybe as much. High speeds can be different depending on how large it is. So there's a balance between the surface area and the speed. So in some cases, air resistance affects falling. In other cases, it doesn't. But when an object reaches the point that the air resistance is equal to the force of gravity, that object will not move any faster. It will no longer accelerate. And it has reached what we call its terminal speed. So for falling objects, we usually call it terminal velocity because the direction is always downwards. So you will see that term, terminal velocity, when an object just cannot move any faster. So thinking about these number of concepts, let's kind of look at our true and false sheet that you answered before. And it's kind of interesting to see that all of these are false. So running through these fairly quickly, without air resistance, suppose that an elephant and a feather are dropped off a very tall building from the same height at the same time. Suppose also that air resistance could be eliminated such that neither the elephant nor the feather would experience any air drag during the course of the fall. Which object, the elephant or the feather, will hit the ground first? And many people are surprised by the fact that in the absence of air resistance, the elephant and the feather strike the ground at the same time. Why is this so? Test your understanding by answering true or false. So number one, the elephant and the feather each have the same force of gravity. That's false. They have different masses. Number two, the elephant has more mass, yet they both experience the same force of gravity. No, they still don't experience the same force of gravity. 3, the elephant experiences a greater force of gravity, yet both the elephant and the feather have the same mass. No, there is not a feather or an elephant that have the same mass. Number 4, on Earth, all objects, whether an elephant or a feather, have the same force of gravity. No, they do not have the same force. They have the same acceleration due to gravity, but not the same force. 5, the elephant weighs more than the feather, yet they each have the same mass. No, the elephant and the feather do not have the same mass. 6, the elephant clearly has more mass than the feather, yet they each weigh the same. No, if it has more mass, they can't weigh the same. Number 7, the elephant clearly has more mass than the feather, yet the amount of gravity force is the same. No, the gravity is still not the same. The elephant has the greater acceleration, yet the amount of gravity is the same for each. No, they have the same acceleration due to gravity. So with air resistance, now consider the realistic situation that both feather and elephant encounter air resistance. Which object, the elephant or the feather, will hit the ground first? Most people are not surprised by the fact that the elephant strikes the ground before the feather, but why does the elephant fall faster? Test your understanding by answering these as true or false. Number 1, the elephant encounters a small force of air resistance and therefore falls faster. That's false because that has nothing to do with why it falls faster. Number 2, the elephant has the greater acceleration of gravity and therefore falls faster. No, the acceleration of gravity is the same. 3, the elephant and the feather have the same force of gravity, yet the acceleration of gravity is greatest for the elephant. No, there is no same force of gravity. Number 4, both elephant and the feather have the same force of gravity, yet the feather experiences a greater air resistance. No, they do not have the same force of gravity. 5, each object experiences the same amount of air resistance, yet the elephant experiences the greatest force of gravity. No, they don't have the same amount of air resistance. 6, each object experiences the same amount of air resistance, yet the feather experiences the greatest force of gravity. No, they don't have the same amount of air resistance. 7, the feather weighs more. I think we can stop right there. 8, both the elephant and the feather weigh the same amount. Nope, they do not weigh the same amount. We can stop right there. 9, the elephant experiences less air resistance and reaches a larger terminal velocity. Less air resistance, a larger terminal velocity. I don't think that has anything to do with this. Number 10, feather experiences more air resistance and thus reaches a smaller terminal velocity. No, I don't think that has anything to do with it. I don't think they've reached a terminal velocity either. Number 11, the elephant and the feather encounter the same amount of air resistance, yet the elephant has a greater terminal velocity. No, they don't have the same amount of air resistance. So I don't know what you thought maybe when you started this, but hopefully thinking about it a little bit more, you're kind of recognizing some of the differences. So in the next video, we're going to focus on skydiving.